Hello, I'm Mark McCord from A-Team Group's Data Management Insight, and I'm here with Vahe Endonians, who's from Cognaize, which has won the most innovative implementation of knowledge graph technologies in the A-Team Innovation Awards 2025. Hello, Vahe.
Hi, hello.
Let me start by asking, what is so innovative about your solution and what challenge are you addressing?
Well, the challenge that we're addressing is the challenge of unstructured data. So the vast majority of data is actually unstructured. And what we mean with unstructured is that it cannot be easily processed by the computer, right? Obviously, it's structured for humans, but it's not structured for the computer. And if you want to use them in an automated way, or if you want to use them in bulk, we need to structure it so that the computer can understand it. And that's the problem that we're addressing. And if you think about how much of data is actually unstructured, is the vast majority of data. And then plus we are producing so much more data now than we produced before that. I think there's this very famous quote from back then, I think Google CEO who said in the last 2 years, more data has been created than in whole humanity before that, right? So we're producing a lot of data and most of it is unstructured, and there is a very high value in this. That's what we are solving.
Right, right. And how did knowledge graph technology change the development and deployment of AI solutions for the financial industry?
Yeah, so I think the knowledge graphs are a very beautiful technology. But before we talk about knowledge graphs, you have to understand what a language model actually does, because that's the foundation basically of AI. When we talk about AI, we talk actually about generative AI and actually about language models right now. Um, And these language models have at their core something which is these embeddings or dense vectors, right? So they translate any kind of text into these dense vectors. And the beauty of these dense vectors is that they capture lots of additional information in it, right? And they do that through technology, which is transformers and self-attention and so on. But if you think about these vectors, they're just an average of something, a very intelligent average, but just an average of something, right? Whereas a knowledge graph is the exact opposite of it. It's a very concrete definition of something, right? So the beauty of language models is that they use these averages, so they can go with semantic similarity, don't need lexical similarity, and so on. But the problem with it is the things that are seemingly similar or have close representations might be very different things in real life, right? And a knowledge graph is capturing that perfectly because a knowledge graph is just looking at concrete piece of information, right? So if you can combine them meaningfully, then you get the best of both worlds. And if you think about the financial industry, very often in the financial industry, when we extract some information or restructure information, right, there is a lot of reasoning happening. Right? Give you an example. If you say what's the maturity date of a loan in a loan agreement, right? Usually the maturity date is never mentioned. It says something like the maturity date shall be 7 years after the closing date if such date is on a working day.
Right.
So which means you have to understand what's the closing date plus 7 years is what's the calendar that they're using, like US, UK, whatever. Is that a holiday or not? And if it is a holiday, what kind of day convention are they using, like +1, -1, and so on, so to get to the actual date of the maturity, right? There's lots of reasoning. If you do that inside of a language model, which many can, you run the risk of being wrong somewhere. And as soon as you add one step wrong, of course, the whole result is wrong. Now, if you do it along a knowledge graph, then you have the beauty that at least it's very transparent. So you can still be wrong, but it's very transparent. So you see exactly along the knowledge graph, how did it go? Closing date was this, and then it went to this, and then this, and this, and shows you exactly where it was. And you can adjust it, right? You can go into the knowledge graph and say like, well, this closing date is actually wrong. That's the right closing date. Then all the calculation gets to be right.
That makes sense. Thank you. And Vahe, what are your plans for further innovation over the next year and beyond?
Well, I mean, I think that so there are a few things that are interesting right now that interest us. We have put a lot of effort into, visual language models, and I think we're pretty advanced in these, and compressing those models. We're also pretty advanced there. I think our field of interest is more now the interaction with humans. So we always believed in what we call this hybrid intelligent concept. So it's a combination of human and AI. Just this combination changes, right? Because the capabilities of AI change. So when we started with a human in the loop in every question is the right thing to do, we now say it's not in every question that you need a human in the loop, right? So sometimes you need it, sometimes you don't need it. And it's a question of when you need it or not, right? And I think the next step would be for us to look at this again, and especially look at this in the terms of how is the interaction with AI happening. For example, how do you actually set up an ontology for a knowledge graph?
Right.
Right now, it is you're giving it, we did it very comfortable, like you can send examples out there and so on, and it works like this. But it could also be, we could also think of just show it AI, like literally open your screen, open a document, show like, hey, this is what I'm interested in, this is what I'm interested in. And AI makes an ontology out of this and creates everything else, right? That one suggestion. And there could be many more. The idea is, I think that any interaction that we are going to have with any kind of computer is going through AI in future. So, and I believe that some of this AI or most of this AI is actually going to be agentic systems. Like they have to do some things and it's not going to be just a prediction level. So we would like to be at the forefront of innovation there. So we're putting some effort into that.
Well, lots to look forward to then. Well,
Thank you.
thank you, Vahe. Thank you for your time. And again, congratulations.
Thank you very much. Thank you. Thank you very much.